let's start. I think very important is what our experts think, which task we can cover with our current driving simulators today, and what you think which tasks we can also cover in the future, and which kind of driving simulators do you think we need. And so I will ask Mr. Sebastian Will for the first statement to this topic.
Okay, this is working. I think that especially from human factors point of view, what we use the simulators for, they are a great research tool for HMI design, for example, with facing certain limits. So our simulators that we usually use are not that highly dynamic, for example, because it's simply not necessary for what we use them for usually. So I think that the limits of the simulator clearly depends on the use case. I guess that the simulator from Volvo, for example, is able to do completely different tests than we are able to do. But I think that the most challenging part still is the motion system itself. So I think these are probably the most well-known limits of use cases for driving simulators. But I think that some of you will go a bit more into detail concerning the motion system. Which I'll hand over.
Okay. Yeah, what we're facing at Volvo Cars, especially since we bought the DIM actually, is that everyone wants to start using the simulator, which is of course very interesting and very fun, but it's also very challenging. So traditionally you can say we've used the simulators first for HMI, which is maybe the more simple task. Secondly, it's active safety systems, and especially the less dynamic ones. Now we can start trying the more dynamic active safety scenarios and systems in the DIM simulator. But also there we have some limitations. So for example, for some of the testing it's actually more useful to have a simulator where you have certain degrees of freedom with a very high performance and very large motion range, etc. While maybe all of the other degrees of freedom may not be present. But coming back to more people wanting to use the simulator, we also now have us at Vehicle Dynamics, of course, that are responsible for the DIM simulator. Powertrain are starting to be interested. We have people from seat design that are very interested in using our simulator for ride evaluation. And coming in now is also complete vehicle testing, which is the department within Volvo that signs off the complete vehicle in the end. So they actually want to have the full experience, which is of course a great challenge. So more or less everything in the end, I guess, is the answer to the question.
Okay, then we go to the next speaker, to Mr. Jan van de Ottela, please.
May I use your microphone?
Yes,
okay.
Of course.
Yeah, I'll take this one. Okay, I have a slightly different perspective, because I think that one of the areas where we'll use the simulator in the very near future is to assess automated vehicles and the way how they behave. Because when you remember my presentation this morning, one of the things we do on the open track is assess a vehicle in its surrounding. But it's also assessing how the driver of other vehicles, the traffic around you, reacts to, for example, an automated car. And I think a good example is the Google car. The Google car has had something like 13 accidents, of which 11 of them are where they have been hit by the back. They had a run-in from the back. Why, we don't know, but it could well be that they are braking in a different manner, that people do not expect the car to brake at moments when it does brake, etc. And I think that's something that we currently do on an open track in a well-controlled environment, but it would be something that you, if we have the right setting, could easily do in a simulator. So from a traffic point of view, also I think there's a good option to extend the use of simulators like the DIM.
Thank you. Then we head to Giorgio Adriano from Brühl & Kjær.
Yeah. Of course, our company, Brüder & Kjær, is a specialist in sound and vibration. Is what we want to do, as was said before, we want to give the full experience to the driver. That includes the full sound. So we have a solution that supports this. We have an NVA simulator that allows to prepare the data to be played back on each on whatever driving simulator. We start this partnership with VI Grade, and we aim to offer the full solution to the customers from 0 Hz to 20 kHz. And we have the proof that when there is the right context, also the performance of, for instance, a Formula One driver they became faster. So that gives a real feedback on how important is the sound perceived by the driver, not only in the video, but also this. And this is also allowing customers that are working in electric and hybrid cars to develop the right sound for inside the car and outside the car. So this is a kind of a solution we offer today.
Okay. Then to Mr. Ullmann from the Audi AG.
Yes, at the moment we are using the driving simulator to develop the vehicle dynamics and also some kind of primary ride until 5 Hz. But we are also interested to do some investigations concerning powertrain development, and maybe in the future, it's not my department, but maybe in the future we'll also develop autonomous driving or driver assistance systems with that.
Okay, thank you. Are there any statements to this question from the audience? Here in some questions. Maybe I see one in the rear.
Oh, thank you again. My question is, for this conference, actually it's very interesting that we didn't talk too much about the autonomous driving, which many people think that's a future for the people. So my question is, what do you think about the motion-based car simulator in the future? Is that only for human, or if all the cars become fully automated, will that be still useful? Thanks.
Is this question directed to a special person, or?
Yeah, I prefer Mr. from Audi because I watched the Audi S7 fully automated car running on the Hockenheim. Fully automated, which is really amazing and very fast. And I'm curious that during the development process of Audi S7, and do you still use a motion simulator, or you just use offline simulation with just computer? And which is faster, human or Audi S7 automated?
Okay. It's a bit difficult to answer these questions because I'm from vehicle development department. I can say that this feature wasn't developed with the driving simulator, so it's a bit difficult for me to answer this question. But we think about to do that in the future, not tomorrow, but maybe in a later time.
Can I? Yeah. Okay, so I'll go first, Sebastian. Yeah, I can say that we're actually already running autonomous drive studies in our simulator. Just currently we're piloting the project before we take in any type of driver, so to say. So drivers that we have currently been running have been somewhat involved in the development of autonomous drive. And more specifically to your question, if the motion-based simulator is important, it's actually even more important because you don't have the cue of the steering, for example. You don't have the direct feedback, so you just have the indirect feedback of the motion of the vehicle. So although some studies have been tried in the static simulator, it's more or less pointless because there's too little information for the driver. So anything which might be uncomfortable or feel unsafe requires a motion-based simulator to represent this.
Yes, I actually would like to add a comment to this point, also to maybe make the discussion more relaxed. So sometimes you drive with somebody that is driving in a goofy way. This could be a robot in the future, because engineers think, oh, okay, the robot must go left, then the robot must accelerate, maybe it's a German engineer, must accelerate, some joke, must accelerate exactly to 38 kilometers per hour, then turn right in 15 meters. It's like a navigator, you know, these girls in Navigator with a strange synthetic voice, then the robot is acting, and you are sitting there in your own car, which costs less and less, but still a lot of money, and then you are driven by this strange person that you would not give him to drive anymore. This is the robot driving. So a driving simulator, at least at the beginning of the prototype of this goofy driver, you can sit in the car, you don't touch the steering wheel, you don't do anything, but can compare what you would do in that scene to what the goofy driver is going to do. Okay, end of my little show.
Maybe I can just add something. I fully agree to what you said. We have one dynamic car driving simulator at our institute, and it's fully booked at the moment, and mainly with questions arising from this automation topic. And one problem is that the automation that we will have in the near future will still face some limits. There will still be situations that the car cannot directly cope with, special construction work, for example, or whatever. And we do a lot of research on how to keep the driver in the loop. Because the big advantage, of course, of automated cars is that the driver is allowed to engage in any secondary task. But if it is necessary, he has to be back as fast as possible. So I think this is one of the big advantages of the driving simulation to assess those problems.
I would like to Diego Minen's statement. Actually, when you drive a lane keeping system, it looks like that you are drunk, no? Because it goes from one side to the other side, and when the police sees you, then I'm sure they will stop you and ask you if you have drunk too much. And I think there's still a lot of work to do. Okay, then I would like to ask the second question. Maybe I start with Mr. Ullmann. How do you think will our vehicle development process change with the help of the driving simulators? Do you think that we have to rewrite the product development process of cars, or is it just a minor change?
Good question. We just started with the simulator project, and we hope that we can change the development process a bit to make it faster and to speed up the development process with that. And in my experiences, or our experiences in our team, is that we have to convince the driver to come to us and to try this tool for their daily work. And I think it is possible to convince most of the driver, and for sure it could be that the development process will be changed, that the drivers come to us in our room and not go to Spain or to Sweden in the winter time so often.
Okay, good.
Well, we have seen that the main customer for our MVA simulator are a sports car manufacturer, and for sure the introduction of the sound exhaust and intake sound simulated through our tools were a way to speed up the development process. And I have the example from Ferrari that bought at the same time the driving simulator from VA Grade and the MVA simulator from us. And it was a way to be more confident on the sound that Ferrari was delivering to the customers. after the introduction of the turbocharged engine, because there was a dramatic change in the product that was delivered to the customers, because they were expecting to have the Ferrari sound from the engine, and Ferrari needs to continue to deliver a specific sound to their customers. And these, each of the sports car manufacturer has his own brand sound. Jaguar, Bentley, BMW, Porsche, Ferrari, Maserati. So these tools, these simulation tools, really helps them to save time and not to go into bad surprises later when it's too late, and if you have to make modification, it will mean that you go on the market with a delay. That means a lot of money.
Okay. Well, it's clear that the development process will change. We will move more to the front end of the system and the development than to the back end today. And the focus will be on validation and robustness in the beginning of the process, where we can still influence cost and we save time rather than the end. So from that perspective, I think that's a given. But a second perspective on it is that we do believe that, perhaps not in the very near future, but we will end up in a situation like we have today in aviation, where we run a virtual homologation, which is done in a world that is using a lot of simulators to develop the product, to train the people that run them, and in the end do a sign-off on the product as such. So from our perspective, and our ultimate goal is to be able to do a virtual homologation on a vehicle, which would be running on a simulator, because there's always a human being involved that has to be, let's say, create the influence of the human being to the system. So yes, from our point of view, there will be a major influence. Yeah.
Okay. Good. Very good comments so far. From our perspective, this is definitely one of the greater challenges right now, to see how we should integrate it into the development process in the most effective way. And just looking at the traditional department, so vehicle dynamics for us, it's the most obvious thing is just that we can make things faster, front-loading the projects more, but not necessarily doing things too much differently. But what it is, it's a meeting place for everyone working with CE, or even not working with CE, but suddenly everyone can understand the CE models. So the possibilities of collaborating within the company or with authorities, etc. I think it's a very powerful tool for this. So in this sense, it will change the process a lot. For example, as I mentioned, for Volvo, it would be the complete vehicle testing that then can come and try our concepts the first week of the project. Otherwise, they come in after 3 years. They have a lot of complaints or positive things for that matter. But I have a lot of ideas of what could have been done differently. And most of the time it's too late. So we can do some patches. But the best thing is they can just accept what we already have. And I think that can change a lot.
I also think that there are changes, or that there will be changes, especially because that quite early in the development process you can get feedback from either professional drivers, riders, or from everyday rider, depending on your focus. Even before you have a perfectly working sensor setup, for example, what usually takes some time before you can go on a test track, for example. So I think this so-called front loading is one of the biggest advantages, and this is what will change the process, I think.
Okay, are there comments or questions from the auditorium which you would like to comment on? Then I would ask what do you think are the limitations of the actual driving simulators from the model side? Do we need better powertrain models or better tire models, or do you think that we are from the model side that we are on the safe side already?
I think what I can answer to this is that it once again depends on the use case. As human factors researcher, I cannot contribute that much to this question. I know what a powertrain is, but this is it mainly. Yeah, I think it depends on what is the use case of the simulator and the use case of the research. But I think that colleagues here can reply something more.
So you're happy with all feedbacks from audio feedback and visual feedback, or?
There's always space for improvement, of course, and it would be great to improve a simulator for a specific task. I think what is pretty well good developed is the visual stimulation. There are quite sophisticated solutions with cylindric screens, with head-mounted displays, depending on the research question once again. But I think what the driving dynamics, what concerns the driving dynamics or riding dynamics, I see a lot of space for improvement in the motorcycle sector, because this seems to be a bit more complicated than for the car, because when we start without velocity, we just fall. What is a slightly disadvantage, of course, so we need to play some tricks on this. But I think that there will be a lot of improvements in the near future, because there are more functionalities for power two-wheelers, there are more assistance systems, there are more information systems, and I think that motorcycle riding simulator can really help addressing these problems, as it is the case in the field of automotive research. So I would say that for the power two-wheeler, there will probably be a lot of improvements in the near future. We are not that far at the moment.
Yeah, I will try not to speak for 10 hours about this question. I think the current setup that we have now, I would say it's rather balanced, which doesn't mean that we have the superior quality in everything, but it's not obvious what to answer to the question. What we at Vehicle Dynamics are mainly concerned with for the moment, that you could also see in our presentation, would be the ride dynamics, which means that we need to increase the frequency range of where our models are correct. And this applies both for tire models, it applies for the chassis model, and after that we have the correct output there on higher frequencies is of course also a question for the motion cueing and what the platform is capable of. And then, yeah, visuals, sound, equally important. And I think what we're trying to do is that we're trying to split up the responsibilities for all these different things so that we can develop them in parallel. So actually the slightly boring answer to the question for our sake is that we're trying to develop everything further.
Okay.
Yeah, indeed, a balance is of course the optimum that you can get, and I think you're right in the answer that a balanced solution is what you need. It depends a little bit on the use case. From a safety perspective, I would vote for the fact that you have the ability to recreate a dynamic scenario on let's say, a double-lane road. And a move like we saw today, where Diego explained that we go from a 1 or 2 meter movement up to a 6-7 meter movement, and we can do double lanes, will improve dramatically the feel that you have in the simulator. So I would say, if I would have to vote for one element, I would go for that specific movement rather than anything else, because it allows you to do a real human interface, do a real study on a driving simulator on physical movements of the car like we see it with automated and ADAS type of systems.
Yeah, talking about the balance in the model, what is currently missing, and we are working together with VI Grade, is also to integrate the high frequency vibration, because we are talking about ride and handling, we are talking about sound. In the middle there is the comfort, the vibration perceived by the driver, transfer from the road to the steering wheel, transfer from the road and all the car body to the seat. So what is possible, and we deliver this to many OEMs, is what we call the full vehicle simulator, that is not the dynamic, but it allows to provide this feedback So some companies can build a better, more comfortable car and make the right assessment of the engine mount support in order to understand before even to test some of the engine mount support they were studying, they were evaluating, they want to integrate into the car before through a full vehicle simulator that reproduce in any driving condition the right feeling, vibrational feeling to the driver. Of course, the future will be to have all these simulators for noise and vibration integrated on a driving simulator. That will be the final simulator that allows to evaluate everything from 0 Hz to 20 kHz.
Yes, like the speakers before, I share their opinion. It depends what you want to do. In my case, in our case, we do vehicle dynamics, and the model is quite good for that. You have to look, to take care about the steering behavior. We take the Pfeffer steering model, as you know, and you have to concentrate on the powertrain, but then it is okay, and then you have a good model. And if you want to investigate comfort investigations up to greater than 5 Hertz, maybe you can have some problems to consider the engine oscillations and so on, the component oscillations, and you need more detailed models. And in the next step, if you have this detailed model, you have to validate it, and after that you need a platform who can apply this oscillations correctly. So yeah, it depends what you want to do, and in our case, I can say if we want to do comfort evaluations, yeah, there's room for improvement.
Okay. Are there questions from the auditorium about this issue?
I have a question. By the way, I have a question.
Okay. Then most of the participants here have owned high-performance driving simulator. Can you give us some advice how to convince the upper management to spend the money on it, and how much prototypes can be saved, and more important, how you can convince the test drivers not to travel to the Nürburgring and instead spend some time on your new driving simulator?
Sorry. Good question. Yes. Okay, let's begin with the drivers. It's a bit easier, maybe. In our case, we go to the drivers and show the amazing system. Yeah, it's quite impressive to come to the sim room and see this big screen and this nice graphic. And so the drivers typically like to try it. And and the most drivers are convinced very easily, and there are some bit stronger cases. But I think it takes time, and as more time you have, and as more people you convince, and it's like a snowball effect in our case. Concerning the management, you have to convince them maybe with a good sim. Maybe it's good to have a sim with less motion sickness. This is most typically the case. The managers go into the sim and drive and say, I'm sick, let me out. And then it's very difficult.
How much the driver could, for example, if they are convince the upper management, because still the driver play an important role in automotive companies, right? So
yes.
So how do you see that? So the driver, for example, is comfortable, has done this, then the manager arrives, first time ever. Maybe he's over 60 years old, so not the digital generation that we need. They put in a driving simulator and he feels sick. What happens? Who is right, the driver or the manager?
Yes, that's right. Depends on the manager. Yes, for sure. Maybe it's not necessary to that the manager feel comfortable in the sim. The driver must. But anyway, some managers are difficult.
Okay.
Anyhow, they are difficult.
Good. So.
Yes, there is a question from audience. Yes.
Yeah, Diego, Frank Kahl from Cruden. In addition to what Richard said from Audi, we have also that experience that it is quite difficult, especially if when you have senior managers who want to do this. And in the process of working with Audi, we on one or two occasions actually advised them not to put senior managers in the simulator and try to get some evaluation or some output within 10 minutes, because usually these people don't have a lot of time. They only have 15 minutes during a lunch break, then they think they can get in the simulator and they come out and they say, oh, it's this and that. And that's a bad idea, so it's better than to not let them drive the simulator at all.
Yes. But sometimes you can, sometimes not. But I have a question regarding the traditional separation between powertrain and chassis development in automotive. How do you see, a question of course for Carl and Richard, that they live this situation every day. How do you see the simulator, beside bridging a gap, let's say enormous gap sometime between testing and simulation, these small bridges between powertrain and suspension, for example? How do you say that? How do you think about that?
It's a good question, but it's something that we actually have some experience with from just the past month, where we succeeded to implement a quite sophisticated powertrain model from our powertrain department. So including the engine properties, the gearbox, hybrid drive, battery management, etc. So first of all, it gives us an opportunity to try all the new engine models and development prototypes in an early stage, which is very good for us. And they, of course, become very interested in using the simulator. So it's not really more complicated than that, than trying to implement someone's model and show what it can do. And I think this is also really a key thing for convincing management now that we've shown that we can do this together with powertrain. This is, I would say, one of the major things we've done with them lately. And collaboration within the company is something that management definitely will approve.
Yeah, we happen to have the same employer, so I wanted to add something. I think one point there as well is that the need for powertrain models is not something to only support DIM in chassis development. I think that is very key as well. It is also required nowadays for stability control and things that communicate with the ECM. So everything that is hill rig related requires powertrain modeling. So I think that is very much a CE shift within the company that is in the benefit of chassis development in the DIM.
Yeah, by
the way,
just a quick comment that the driving simulator is a very good entry point, because you can show the other group that we're doing this. Isn't this interesting? Wouldn't you like to try your model here? And then when we've implemented in the simulator, it's much more easy to implement it in all the other environments.
Well, for us, powertrain, half of our customers are from powertrain, and the other half is for vehicle NVH. At the end, our NVH simulator is putting all these people together, because they can, when we are talking about powertrain, we are talking about sound transfer and vibration through the engine mount support. So this is something that we can assess, and we can help our customer to simulate and create the right model, the right performance model, and the right feedback in terms of sound and vibration to the driver. So this is the core of our proposal to new customers. Through our simulator, we will allow you to design the right powertrain feeling to the driver.
Well, small comment from my side. What we see clearly is that the cones are shifting and that the roles of a specific department are not the roles that they used to be 5 or 10 years ago. So whether you're testing or design, whether you're doing development or something else, you will, in the end, will need to use the same type of tools. Perhaps in a slightly different setting, with a different aim, but in the end, the basis should be the same to do a proper, quick, and efficient development. So I agree that a simulator is a good start to collaborate, but further on in the process, people will continue to do the same. And the same driver that goes now every second or third month up to Kilimanjaro or somewhere else to have a good drive, he will still go there, but he will be looking at different things than what he's doing today. And the guy that is complaining about it today that he has to go every month is the same guy that is resisting to go, because we all have a framework which is built on our, let's say, our history. And we have to accept that the framework, what we see today, is probably not a framework for the future. That's why I agree, yes, managers should leave certain decisions to a different type of setting. And the best example that we have today, I think, is that the biggest growing sector in Germany is the automotive and electronics industry. And if we look at the combination of the people that is out there, then most of the OEMs will have as many software engineers as big IT companies like Google or Apple will have in the future. And that is the reality that we're facing. So somebody that is working from a mechanical background, that's fine, but he will have to learn how things work in a different environment as well. And that combination will prove we're in a transition phase. That's difficult, but the car of the future is not a mechanical car anymore. It's an electronic car.
Maybe a last short comment on how to convince the management. I think what was already mentioned, money is of course a very important argument. But besides that, one should not forget that it is advantage for the driver or the rider, him or herself, because crashing a car on a test track is not that really good for health. But in a simulator, you can do this over and over again and push kind of the limits without getting hurt in a completely safe environment. So this is maybe a small advantage of simulation too.
I would like to ask an additional question on this field about human beings. Do we understand enough about the behaving of human beings in simulators and in real world, and what the differences are? Or do you think there's a lot of research what we have to understand to link the real world to the simulators?
I think we know quite a lot for people that drive a car. Still, there is a lot of things that should be investigated in the near future. There are some validation studies that investigate how people react on a real car on the test track and compare this with the reaction in the simulator. I think it's important that we are not always interested in the absolute values that we get out of this research. Sometimes it's enough to have the same tendency, let's say, so that any rider assistance system that helps the driver in the simulator should also help him out on the road. Maybe it's not important if it helps by, I don't know, decelerating by 4 meters per second square or by 3 meters per second square. It's not about this, but it's promising if it helps in the simulator already. And we know quite a lot about how people behave in the simulator, and there are some nice methodologies to assess these questions, also with parameters that cannot be changed by the driver himself. Like if you are on a small, tiny road and you ride at very high speed, for example, your skin conduction level rises, and you cannot influence this. And if the same happens in the simulator, it's a good hint that the situation is comparable. Just one comment for the motorcycle sector. I think here we do not know that much about how a motorcycle rider behaves. And there is a huge gap between how the rider behaves and how he thinks he behaves. And this is also very important if we focus and if we investigate what did the rider do, how did he react. This huge gap should be addressed if it's of importance to the specific question.
Yeah, I think we do know a lot, and there's still a lot more to be understood. But I think that the simulator is also a great tool for actually helping us understanding. So even though we need to understand the driver's behavior and how he appreciates everything in the simulator, that's one challenge. But it can also help us understanding the human in an even better way. For one example, in the driving simulator, we have the opportunity to only provide the driver with single cues, as we saw in your presentation, that you have only visuals or only sound or a combination of those two, and you can do these factorial studies that are impossible to do in real life. And of course it's real life that matters in the end, but that can definitely give some clues of where we should put the most of our attention to. And for vehicle dynamics, if I take that specifically, as that's what I'm working with, because we have so much data available in the simulator with much less effort than we have in a real car. We have all the objective data of the simulation, so we can see exactly what the driver reacted to. We cannot do this in reality to the same extent. So that gives us a very powerful tool.
It's a difficult question, because on the one hand we are very satisfied with the level we have achieved, and on the other hand we know there's still a long way to go. So it's for me it would be difficult to put out and say, have an absolute statement on and say it's sufficient or it's not. I think we have some areas, like you pointed out on vehicle dynamics, where we have a good feel, where we have a lot of experience from the past, but there are a lot of other areas where we don't. So doing proper investigation, making sure we collect as much data as we can, also from the human and the neural part of it as much as possible, is something that is really needed to go forward. And perhaps we need other people than just electronic people or mechanical people on board, and we need somebody from medical industry or somebody that has done a neurology study to really make sure we understand the difference better than what we do today. So I would promote for more investigation in that area than anything else. Yeah.
With our simulators, we have indirect and direct feedback from what the driver is doing, what is his experience. Of course, an indirect feedback is we can see adding the right sound or not if it's changing the behavior on the driving. But not on driving simulator. On our static simulator, what we can use is jury software, jury evaluation tools, semantics and everything. So what we can put beside the driver is a tablet with some possibility to vote on their experience. And if there is a benchmark running, so we can understand from the way they decide which is the best car in the panel, we can record all the history. We can understand in which way the driver went to his decision. This is a sort of feedback we can have integrated in our MVA simulator. That becomes a little difficult if we have to install this on a driving simulator, unless we ask for, let's say, a vocal feedback on which one it prefers. So it could be a tricky application to integrate a jury evaluation tool on a driving simulator, but something interesting, I think.
Yeah, in my point of view, in our case, we are developing vehicle dynamics, and we are still fighting with the discussion not to have the real accelerations we have in the real car in the sim. This is a big discussion point, and in my point of view, we will or we should make a stroke in the future concerning that point, concerning motion cueing and driver perception, to get the driver the feeling of a real car, and so I think this is a big point. And in the other hand side, like Carl mentioned, we have the possibility to understand the driver's behavior in a car, which we typically can't do in the real world.
Okay, are there any comments from you to the question? Then there's one.
First of all, I would like to thank VI Grade to organize this conference, and also for having an open session to discuss about the current and future trend related to vehicle simulator. We have discussed many things related to vehicle simulator, current and future, related to issue, related to management issue. But one point that I didn't find, what about the emission? I mean, when we are talking complete vehicle simulator, then I think we have to also consider for emission dynamics or simulator, what you can say. So, do you have any points to say?
Does anyone make a comment on emissions of? I think the question is to optimize emissions in driving simulators for real cars, or is this the question?
Yeah, but we have discussed here powertrain dynamics also related to, in future, if you are combining vehicle driving simulator with vibration or powertrain, then we have to also consider for emission, because as we know, emission is also a big headache for us.
Well, I start, we deal only with noise emission. And I'm saying only, but it's not only, because if you don't get to the right value, noise emission, you don't get your car homologated, and so you cannot sell the car. So noise emission are important, but I'm not sure you were talking about noise emission. You were talking about engine emission, right?
But I think, as far as I know, with the coming legislation and real driving emissions, that simulators will really play a very, very big role to prove if the real driving emissions are okay. That's my point of view.
Well, to a certain extent, we already see that in practice, because with Euro 6, you have to prove that you're able to have real-life emissions rather than a circle or a bandwidth that you drive, and prove that you have a proper setting on it. The next step will be that also the driver will be involved, and where we see today that with the e-Horizon and the fact that we have a simulated environment to run those type of tests and to do a proper setting on it, the next step will be that in a driving simulator you will be able to do that. So I don't expect that to be something very special. It will be a natural move where you will have emissions connected to the rest of your settings.
I agree fully. And I think the fact that we can now integrate our more advanced powertrain models, etc., for especially our collaboration with drivability, means that we can try a lot of novel propulsion systems. For example, you probably all know that the combination in hybrid vehicles between the combustion engine and the electric motor is actually something quite challenging. And the interaction between all of these control systems and actuators and the driver is very important for how the driver can have a smooth and comfortable ride at the same time as the emissions are kept low. So including the driver in the loop here is of course useful, apart from just offline simulation.
Okay.
Just a short remark. Maybe it's a bit off topic, but related to emission. What we have not mentioned yet is that simulator can also be used for training purpose, for example. So one could make use of the simulator to train people in riding kind of more fuel efficient, for example. So this was what we didn't mention before, just came up now because of the emission.
Okay, then now I would like to start my last question round. Maybe I start from, do you want to start? What do you think are the future trends in driving simulators, and what do you think is the impact of the virtual reality? Does the virtual reality change our driving simulators completely, or do you think we have the same layout? And the small additional question is, which kind of driving simulators would you buy when you want to buy one next time? You don't have to mention that it's a VI grade one. We know that already.
Maybe one for aviation, because I've never flew a plane so far, so I would go for that. Yeah, I think there will be changes in driving simulator setups. If I remember one of our first simulators that was built in the late 90s, it had a slightly kind of different look than it is today. I think there will be improvements, for example, if the head-mounted displays are getting better. One could reduce the size that is needed for a simulator, for example, because at the moment we need for specific research questions a quite huge field of view, so we need a huge hall, a room, we need 4 projectors or 5 projectors, even more, a huge screen, so we could have a completely different setup. And I also think that it's a future trend to address more sensory cues, or in a different manner. It was mentioned today, these proprioceptive cues, this rope tying mechanism, this tugging the seat belt, for example. These are quite interesting new cues, and I think they will help to give the driver an even better feeling of being part of this virtual environment, and I think there will be even more of this kind of playing tricks on the driver in order to get the proper feeling of being in a car, for example.
Okay.
Yeah, we're seeing both more high fidelity models and different gadgets, basically, for virtual reality popping up, such as the virtual reality glasses. One specific challenge with these are that you won't see your own hands, you won't see the cockpit, which makes it troublesome for a lot of the testing. As fidelity improves, this may not be a problem in a few years, but it also gives the portability of these devices, gives some interesting ideas of new types of simulators. For example, you could drive a real vehicle, but in a virtual world. It's something that's experimented with quite a lot. And you can have the portability of all these things gives, very interesting combinations between the virtual reality and the physical world. So you don't need to necessarily restrain yourself to one or the other. And I think that's something that's going to change. And how it's going to change, I don't know.
Okay.
I fully agree with your comments, and what we call virtual reality, in fact, is high fidelity in an area where we think it should be ours. I do expect that it will change the way how we develop. I think we will see self-learning systems in a virtual world, which we calibrate and have a look at. And I think that indeed at a simulator level, you will be able to go away from a big screen, sit in the car and just look on your windows, and you will have the world outside there as a reference, which will change the way how you do it. We've built vehicle-in-the-loop cars where we project on the front screen, but it's still an image that is not good enough to represent the actual reality. As soon as we're able to do that, you can go to a different methodology, and perhaps you will drive on an empty airfield with a car, blinded, but looking into a virtual world. So yes, I buy into the idea, and I would support to develop.
Yeah, I also agree, and we would see further development and further adding features, adding functionality, having these kind of simulators to help to develop also the rest. We were talking about the powertrain, we were talking about the ride and the handling. I know that there are companies there already start to build simulators for the clicks, just to simulate all around on the dashboard or the wipers, and everything will be simulated in some way in the future. Well, already today, I think.
Yeah, I think maybe in the future it could be that there is a combination of the head-mounted displays, which get better and better, in combination with some crazy new motion platforms, maybe.
Okay, then I would like to thank all of the participants and to you that you have also participated in this discussion. And then I would like to say thank you to Diego and would like to hand over.
Yes, well, thank you, Professor Pfeffer, and all the participants to this interesting discussion. We don't have the chance very often to have this type of things, and in recent years at VIA Great Conference we have experimented this type of open confrontation of ideas on what is used and what we think is going to be used, and I hope it has been of some value for you listening. It's always difficult to make it completely open. We would need much more time. Now, what is the schedule? What Gabriel announced before, so we can close. Jonas.
Hi. Concerning the following evening event, please make sure to be here latest at 7:20 p.m. for the last bus going there. And for those of you going there by car, please refer to the address we provided you in the logistics sheet, because there are two Jagdschlossplattes actually in Wiesbaden, and the other one is on the other side of the city. So Jagdschlossplatte in Platterstraße is the place to go. Thank you.
Okay, thank you all very much, and see you later.